In this video 4.7, we are going to be looking at similarity and indirect measurement. By the end of the video and work time in class, you should be able to say, I can solve proportions with similar figures. Indirect measurement is a way to use proportions and similar triangles to measure distances that would be difficult to measure directly. So we're going to be doing things like finding the height of a flagpole or the height of a tree, the height of a building, the height of a stoplight. Finding those heights or those distances without actually measuring the actual object. We're going to be using a proportion. So in this first example, we're going to draw a picture. So I want you to, we're going to draw like a flagpole over here. So here's our flag that we have just kind of sketched out. Okay. And we are going to be finding out the height of the flag. So that's the unknown. And then we have a person. We're going to put a person. Here's my wonderful stick figure here. And that person is from head to toe 6 feet. And then the sun is shining, and the flagpole and the person, they both have shadows. And so I'm going to represent the shadow here with my green marker. The shadow of the person is over here, this distance. And I'm going to say that that shadow of the person is 17 feet. And then the flagpole has a shadow, a bigger shadow, and that shadow is 51 feet. And what happens is we draw a line coming down here, and what we see here by drawing in this line, this is like a ray, let's say like a ray of sunshine coming down. What we see here then are two triangles. If you look here, the two triangles are formed. The first one here is formed by the height of the person right here. So from here and then here, the red line and the shadow, that's one triangle. Then we have the height of the flag, and we have the flagpole. We have that red line that I keep tracing coming down, and then we have the shadow making a bigger triangle. So we have two triangles. These images, or these triangles we're seeing here, are similar. And because they're similar, we can find the height of the flag by setting up a proportion. The height of the person, 6 feet, is to the height of the flag, x feet. The shadow of the person, 17 feet, is to the shadow of the flag, 51 feet. And so you can see in my proportion what I did is I went person to flag, person to flag, or big, or I'm sorry, little to big, little to big. So here's my proportion. Now I solve. I can cross multiply. I also know that 17 times 3 is 51. So whatever I do on the right side, I do to the left side coming down here because the x is on the bottom. I multiply by 3, and I know 6 times 3 is 18. So the flagpole is 18 feet. So we just found the height of the flag indirectly. This is called, once again, indirect measurement when we have similar figures, which are the two triangles. In this next problem, we're going to draw two triangles again. So there it's kind of, you can see two triangles. It should be a little straighter here. Okay. And I'm going to say that this is triangle A, B, and then C would be right here. And this is triangle, and we'll put an E here and a D here. So EDC. So I'm saying that triangle ABC is similar to triangle EDC. And so because they are similar, their corresponding angles are congruent, their corresponding sides are proportional. So now I'm going to label some of these. This is a right angle, and this is our right angle over here on the smaller one. I'm going to tell you this one here is 416 meters. This distance from B to C up here is 312 meters. This distance from C to D is 141 meters. And from D to E is an unknown, that's a variable. So we're going to figure out D by setting up a proportion because we have the distances or the lengths of corresponding sides to set up a proportion to find that unknown. So 141 on the little triangle is corresponding or matching to 312 on the big triangle. And on the little triangle, the D is corresponding to 416. So I'm going little triangle to big triangle, little triangle to big triangle. And I can cross multiply. 416 times 141 is the same as 312 times D. So you do 416 times 141, you get 58,656, and then you have to divide by 312, and that D, the distance of D is 188 meters. And we found that distance without measuring it directly. We set up a proportion because we had two similar figures. Can you say, I can solve proportions with similar figures? Here's your output to work out in your interactive notebook. Be prepared with any questions for the work time in class.